Hello students. Okay, so in this particular assignment, our focus now shifts to the cone, the pyramid, as well as the sphere, right? So here are some examples to apply the formulas for each of these figures, right? So down here we have a container, as you can see, it's made out of a cylinder on top and a cone in the bottom, right? So what do we have here? We know that the radius is just given as r, and the height of the cone is given as 4r. We are also told that the volume of the cone is actually 7 liters, but they give it in terms of liters. So, but what we know, right, 7 liters, if we want to convert it to the units that we are more familiar with, is actually 7 times 1,000, 7,000 cubic centimeter, right? Or sometimes just called cc. Some you may hear some people use that abbreviation. So this is fine, right? So these are information we have. And what are we supposed to do? We are supposed to find the amount of water to fill the container. So basically, we are supposed to find the volume. Okay, so but we can't just find the volume like this. We need to find out what is the unknown r, right? Without the radius, we can't find the actual volume, and so you look at it this way. So the first task or the first thing that we need to sort out is what is the value of r. So in order to do that, we need to do some comparison based on the information that we have. And the comparison that we have right now is that the height of the cone is 3/5 the height of the cylinder. Okay, so you notice that just like in the previous assignment, this kind of a proportion thing actually plays a part as well in this particular unit, right? Okay, so here we go. So to find the height, this is how we go about doing it, right? So the height is of the cone is actually 3/5 of the height of the cylinder. So how the cylinder is 4r, 3/5 of that gives us 2.4r. So we have the height of the cone in terms of r, and now we can go on and find the volume of the cone because we already know that it's 7 liters. So volume of the cone is 7 liters, which will be 7 times 1,000 cubic centimeter, and it's also the same as the formula, okay, to find the volume of the cone, of course, right? So it's 1/3 pi r squared times the height, which is 2.4r, and that works out to 0.8 pi r cubed. Okay, so to find r cubed, just take 7,000 divided by 0.8 pi, that gives us 2,785.2 something something. It goes on. Okay, and then we just take the cube root of it. Our radius is about 14.070 centimeter. Okay, so we found our r in this manner just because of the comparison that they give us, whether they give us comparing the height or comparing the volume or whatever, right? So using that information, do some equating, and we managed to find the radius. Now that we have the radius, we can go on to find the actual volume. So there are two parts here. Volume of the cone, we already know, right, is 7 liters. So let's find the volume of the cylinder. Okay, so volume of the cylinder is pi r squared times height, which we already know. So it's pi r squared times 4r, right? So of course we know what our r is. Substitute the r with the value 14.070, and it works out to 35 liters. Okay, so the volume of the cylinder is 35. The volume of the cone is 7. Therefore, the volume of the entire container, 35 plus 7, 42 liters. Okay, right. Moving on. The next question, this time round we have a hemisphere and we have a cone, right? So the radius of the um, base of the cone and the hemisphere is given as 35 centimeter already there. Okay, so just like the previous question, we are looking out for some kind of comparison as well. So this time around, what are we comparing? We know that the volume of the cone is equals to 1 and 1/5 the volume of the hemisphere. So that 1 and 1/5 is of course 6/5. That means the volume of the cone is 6/5 the volume of the hemisphere. So that's the information we have. So the first thing we ask to do, find the height of the cone. So what do we do? Well, we need to find the volume first before we find the height, right? Because yeah, we need that information because all we have right now is the radius, not enough information. So let's find the volume. So volume of the hemisphere, we can find straight away because all we need to find the volume of hemisphere is just the radius, right? So volume of hemisphere is half times the volume of the sphere. Volume of the sphere is a 4/3 pi r cube, right? So 4/3 pi r cube, volume of the sphere, half it to find the volume of hemisphere. We have 28,583 and 1/3 pi. Okay, so yeah, because I'm putting it in slides, it's not that easy to write it in fractions, so I 0.3333, right? After that, okay, what we do next, okay, we know that the volume of the cone is 6/5 of the volume of the hemisphere, right, from the question. So multiply by 6/5, the volume of the cone is 34,300 pi. Notice I leave the pi here because the question did say that we are supposed to leave our answers in terms of pi. So it's okay to leave the pi here. We don't have to actually work it out yet. Just leave it there, right? So finally, to find the height of the cone, let it be h centimeter. So applying the formula, right? 1/3 pi r square h. This is the formula for the volume of cone. Is equals to what we have calculated, okay, 34,300 pi, right? So we take this value, okay, 34,300 pi divided by 1/3 divided by 35 square. H is actually 84 centimeter. Okay, so successful. Okay, of course, a good habit. Since this is a word problem, please just write down a proper statement to conclude. Answer to the question. That's what we want to do. Okay, so that's part one. Part two. This time around, they want us to find the total surface area of the solid, right? So total surface area of the solid, a few things needs to happen. The surface area for the hemisphere is just half of that of a sphere, so that one is easy. Now, in order to find the surface area of this curved part of the cone, right? We need to know the slanted height, which is this length over here. You can see my cursor. Okay, so in order to do that, we actually apply another mathematical theorem, a very famous one, known as Pythagoras Theorem. Okay, so for students who are not familiar with Pythagoras Theorem, you may want to take some time to read out about it. It's very useful. Of course, if there's time in class, we will actually talk a bit about that as well. Okay, so using Pythagoras Theorem, the slant height of the cone can be calculated in this manner, right? So it will be this length over here, the height, 84 centimeter square plus 35 centimeter square, which is this height, and then we square root it. So Pythagoras theorem works on right angle triangle, and as you can see here, my cursor is tracing out, this is a right angle triangle. So you work it out, this length over here, the slanted height is actually 91 centimeter. So after that, it's just applying the formula. Total surface area of the solid, we know that the curved surface area of the cone is pi rl. Okay, so pi times the radius times the slanted height plus 2 pi r squared for the hemisphere, right? Because 4 pi r squared is for the whole sphere, 2 pi r squared for the hemisphere. Okay, work it out. We have 5,635 pi. Okay, we leave our answers in terms of pi because the question requests us to do so. Okay, so that's the second question. The third question that you're told to try is this. This time round, we want to look at the pyramid. Okay, so we have a pyramid here with a height of 28 attached to a cuboid as a base, right? Square base. Okay, so when it's square base, we are happy. It's easier to wrap our mind around it and to do our calculation. Okay, so to find the volume, of course, two parts here, volume of pyramid plus volume of the cuboid. So here we go, volume of pyramid plus volume of cuboid. So volume of pyramid is 1/3 base area times height. Okay, so you need to learn how to apply this formula. So 1/3 times base area. So you look at the base of the pyramid is 30 centimeter by 30 centimeter. So 30 times 30 is the base, and the height is 28. So this portion here is the volume of the pyramid, and volume of a cuboid, length and breadth times height. That one we are familiar with, right? So add them up, we have 44,400 cubic centimeter. Now, for the total surface area, okay, what do we have, right? We have the, again, for the cuboid, 5 of its 6 faces is actually exposed, right? The 4 sides and the bottom. So that one is just a rectangle or squares, right? We just need to add them up. How about the pyramid? The portion that's exposed for the pyramid, the lateral faces, okay, they are actually triangles, okay? However, the base of the triangle, we know we can see that they are 30, but the height of the triangle is actually this slanted height. So just like the previous question, we need to calculate and find what the slanted height is. And if you look carefully, if I trace the height of the pyramid with half the base over here, and the standard height, this is actually a right angle triangle. Since it's a right angle triangle, we can apply Pythagoras theorem. Okay, so Pythagoras theorem, after you do some research and read out on it, we know that this is how we use it. The standard height, okay, of the pyramid this time round will be square root of 15 square, which is actually this side of the right angle triangle, plus 28 square, which is this side of the right angle triangle, which is also the height of the pyramid. And then we square root it, which gives us 31.76476 centimeter. So that's the standard height, which is the height of each of the triangular lateral faces of the pyramid, right? So with that, we can actually calculate the total surface area. So first of all, we have the area of triangle, which is half times base times height. So half times 30 times the height, which is the standard height, 31.76476, which is this portion here. And since we have four identical triangles like this, okay, on the pyramid, so we multiply by 4. And then, of course, we have 4 times 30 times 40. 30 times 40 is the side of the cuboid. So there are 4 of them, right? All 4 sides are the same sizes, so multiply by 4. And finally, we have the base of the entire shape, which is 30 by 30. So add them all up, okay, round off to 3 significant figures. We have 7,610 square centimeter for the total surface area. Okay, so with these questions, no, I hope you are more familiar with how we apply the formulas for pyramid, spheres, and cone, right? And you learn something. So let's continue to learn, continue to gain better understanding of this chapter. Okay, keep practicing and keep improving. Have a nice day.